let's get our approximations or our guesses. The degree is 4. The leading coefficient is 1. So we know our end behavior is up, up. And since the degree is 4, we know it's going to be some sort of W looking thing. We don't know how warped it's going to be, but that's kind of what we're going for. Okay? And normally we would make an XY table. That's what you have done in the past, in your history. You make up some X's. You just make up whatever you want. You plug them in, and you see what you get. And that would still work, but we're going to use synthetic division to make the process quicker. Okay? You can do synthetic division in your head, taking all those numbers to the 4th power and then to the 3rd power. That's not very quick. All right, so we're going to do something that's quicker. First, let's review synthetic division. In this case, I'm going to set up synthetic division using the function. There's a ghost term at the end because we're missing the constant. So it's 1, 1, -4, -4, 0. And we're going to synthetically divide by whatever we want. -2, that's the first number in my XY table. So I'm going to synthetically divide by -2. You don't have to do any opposites when you're doing this. Whatever you want to do, whatever point, whatever x you want to find the point for, that's the number you synthetically divide by. Okay? So I'm going to drop that 1. Okay, now remember what we do. We take -2 times 1, which is -2, and I add these two to get -1. You remember that process? Okay, so now what I'm going to do to speed this up is I am not going to write that middle row where that -2 is. I'm going to do that part in my head. Okay? So the next one. -2 times -1 is 2 plus -4, -2. That's going to make the process much quicker to not write that number. -2 times -2 is 4 plus -4, 0. -2 times 0 is 0 plus 0 is 0. Okay, so what does that mean? The remainder is the y-coordinate. So a point on our graph is -2, 0, which you would have found by putting -2 into the function. So by putting -2 into the function and cranking out an answer, you get the same number you get when you synthetically divide by -2 and take the remainder every time. So -2, 0 is on our graph. You can see the point's been up there for a while. Now, I don't want to ruin my entire slide up there with a whole bunch of synthetic divisions all over the place. So what I do is, I'm going to make a chart for my synthetic division. And since I'm not going to be writing this middle row anymore of this synthetic division, all I'm going to be writing is this. I'm going to set up my chart like this. Okay? And you're going to be able to go through these. Once you get in rhythm, you're going to be able to fly through these. It takes a little time. It takes some warm-up time. You got to practice it a little bit. But once you get going, you're going to be fine. So let's go to -1. When you set up a synthetic division chart, you want to do numbers that are in sequential order. You don't want to bounce around and go from -2 to 5 to 0 to 3 to -6. You want to do numbers that are in order so you can see where you're going. And as we do more problems, you'll see what I mean. So, That first number, remember, we bring straight down. In fact, when you set up your chart, you can just drop that number all the way down. Because every time you start off dropping that number, remember gravity in synthetic division? So to get things started, you can just put that number there so you don't forget. So here's what it looks like in a chart. Here's what you're doing. Negative 1 times 1 is negative 1 plus 1 0. Negative 1 times 1 is negative 1 plus 1 is 0. We're doing the same thing we did up here, only we're kind of doing it in our head. Okay? The next one would be negative 1 times 0 is 0 plus negative 4, negative 4. Negative 1 times negative 4 is 4 plus negative 4, 0. Negative 1 times 0 is 0 plus 0, 0. So now we have a point on our graph, negative 1, 0. So that's what we look like so far. We don't know where we're going with our little W graph, but we know we go through those two purple points. So now we move to 0. Move to the next number. 0 is very easy to synthetically divide by. 0 times 1 is 0, plus 1 is 1. 0 times 1 is 0, plus negative 4, negative 4. 0 times negative 4 is 0, plus negative 4, negative 4. What do you notice about the 0 row? It's going to mimic the problem. It's going to look just like the problem. So whenever you're synthetically dividing by 0, you can just write the last number in the remainder. Because that's really all you care about in these is the remainder. So whenever you're synthetically dividing by 0, just drop the constant down, and that's going to be your y coordinate. So another point on our graph, 0, 0. How many roots could this thing potentially have? 4. We've already got 3 of them. Once we find a 4th one, we're pretty much done, because there's not going to be any more action with our graph. Let's try 1. 1 times 1 is 1 plus 1, 2. 1 times 2 is 2 plus negative 4, negative 2. 1 times negative 2 is negative 2 plus negative 4, negative 6. And 1 times negative 6 is negative 6 plus 0, negative 6. So now we have a coordinate at 1, negative 6. Right there. You think it's going to go down forever? No. No, because look at our end behavior. I predict a rebound in our graph because we should be going up to infinity. So let's go to 2. 2 times 1 is 2, plus 1, 3. 2 times 3 is 6, plus negative 4, 2. 2 times 2 is 4, plus negative 4, 0. 2 times 0 is 0, plus 0, 0. Looky there. We have a 0 at 2. So far, we have our 4 zeros, and we have a valley type point that shows that our W is going to dip there. Normally what I do is I go one further just to make sure that everything's going well. So to synthetically divide 3, is everybody following along with this synthetic division chart? Hunter, are you following along with all this? 3 times 1 is 3 plus 1, 4. 3 times 4 is 12 plus negative 4, 8. 3 times 8 is 24 plus negative 4 is 20. And then that's going to be a y-coordinate of 60. Does that jive with what we want to happen? Yeah. Gone at 360. How about the other side? I'm going to erase the negative 2 in my synthetic division chart. You can just put yours at the bottom if you're writing all this down. I'm going to do negative 3. Make sure we leave in the right spot on the other side. Negative 3 times 1 is negative 3 plus 1 is negative 2. Negative 3 times negative 2 is 6 plus negative 4 is 2. Negative 3 times 2 is negative 6 plus negative 4 is negative 10. Negative 3 times negative 10 is 30 plus 10. So we're at negative 330, which is way up there. So now what we have to do, which I could ask any kindergartner to do, is draw a line through all of the purple points. And it should look something like this. When you get to these ones here, you don't go straight across. You got to have a little bit of a loop-de-loop. That doesn't look very good. There, that's better. So we have a W that kind of is melted in one valley.